This is Dr. Sridhar back to you with another video session on single phase transformer. And in today's video section, I am going to discuss about the principle of operation of single phase transformer and various applications of transformers in distribution and transmission systems along with the generating stations, and why this transformer is widely used and one of the major component in power system. What made this transformer becomes one of the major component in power system. And in addition to that, how can we calculate the efficiency of the transformer and voltage regulation of the transformer, and how can we draw the equivalent circuit of the single phase transformer. So in this today's video session, we are going to discuss about these elaborately. So before starting to the single phase transformer, let us discuss about the importance. Now you can see in any transmission, generating and distribution systems, the transformer is a widely used component. Almost more than 90% of the machines are the family of transformers only. And this transformer puts up excellent efficiency. It is almost more than 95% of efficiency the transformers will have. What made the efficiency becomes very excellent in the single phase transformers or in the three phase transformers? The only one reason is nothing but this transformer is a static piece of apparatus. It means there are no rotating bodies in the transformer. Once there are no rotating parts or rotating bodies in any electrical machine, now automatically the mechanical losses becomes zero. Once the losses are going on reducing, then proportionally the efficiency of the machine becomes more and more. So this makes the efficiency of the transformer is very high. More than 95% of the efficiency the transformers will put up in the transmission systems and generating and the distribution systems. So in view of this and because of these advantages, now first of all, let us discuss about what is the principle of operation of the single phase transformer. Now basically first it is a electromagnetic energy conversion device. Electromagnetic energy conversion device means, now if you could see the simple circuit here, this is the primary side. This transformer is nothing but it will have a magnetic core. Now this total core is nothing but, so this is completely, it is a magnetic made with a magnetic material, and this is called as a core. Now this allows some amount of magnetic flux pass through it. So what is the direction of this magnetic flux means it will be decided by the current associated, and what makes the flux to flow in the magnetic core, that is nothing but the current. The current is a parameter. It will decides the direction of the magnetic flux, from which direction to which direction the magnetic flux has to flow through in the magnetic core. So this magnetic flux is indicated with the dotted lines here. Now this is the magnetic material completely. Now on the left side, if you could observe here, now here these are there are few windings are wound on the transformers one side, and on another side of this transformer or this magnetic core, let me say first magnetic core only, after that this total set becomes transformer, of course. Now here on another leg or limb or another side of this transformer, there are few more windings are wounded here. So this is a place, and these windings, across these particular windings we are going to connect the load, and across these windings we are going to connect the supply source. Now this is the supply source we are connecting to the one side of the transformer, and load is we are going to connect on the another side of the transformer. So through to which windings the load is connected, that windings are called as the secondary windings. To which part of the transformer or to which portion of the windings the source is connected, majorly that winding is called as a primary winding. So primary winding is nothing but it is a place to which or across which we are going to connect the supply voltage or source voltage, and secondary winding is nothing but the now across which we are going to connect the load. So secondary winding across this, the voltage it will be measured as a V2, and how many number of turns will be there in the secondary windings means N2 is nothing but that is a letter we are going to use to represent the number of turns or number of windings in the secondary. And similarly N1 is nothing but this is a letter we are going to use to represent the primary turns in the primary winding or primary winding. How many number of turns are there in the primary side of this transformer or this magnetic core, that is nothing but the N1. So the induced EMF, of course, we will talk about that induced EMF once this brief introduction completes. So this is the supply voltage. It will be connected to the N1 number of turns, and load is connected to the N2 number of turns. And once the supply voltage is switched on, suppose if the supply voltage is switched on, then automatically this primary winding will carry some amount of current through it. That current is nothing but, let us assume that is the primary current, or the current available in the primary winding, that is I1 current. Whenever this I1 current flows through this N1 number of turns in the primary winding, every current carrying conductor produces its own magnetic field, and moreover, the supply source is nothing but alternating quantity. Alternating quantity, which is nothing but the time varying quantity. It means as the time progresses, the magnitude of the current as well as the voltage will also vary. And once this I1 only drives some amount of magnetic flux, because as per the Ampere's right hand thumb rule, every current carrying conductor produces its own magnetic field. So based on the thumb rule, as per the thumb rule, so the direction of this magnetic flux produced by this I1 current is traveling like this. Because see, the current is nothing but just hold this leg, this portion of the leg in right hand, and you please keep your thumb in the direction of the current, then the remaining fingers indicate some magnetic flux direction. Based on the same thing, we can easily identify, or we can easily predict the direction of the magnetic flux. So magnetic flux is, so it will be driven by this I1 current, and it will flow like this through the magnetic core. For the simplification, we are representing only one flux line, but of course there will be a bundle of flux lines or group of flux lines. It will begin at primary winding of the magnetic core, and it will pass on to the secondary winding, and it will like this, it will complete its path. Now this is the flow of magnetic flux once this primary winding is excited with V1 voltage source. Now here, if you could observe here, now through this N2, what happens, this time varying flux is passing through N2 number of turns, and this flux is nothing but it is a time varying flux. Whenever this time varying flux passes through, time varying flux is nothing but time varying magnetic field passes through the some few number of turns, then automatically what happens, there will be an induced EMF. That induced EMF is nothing but E2 is nothing but, this is the induced EMF we can observe across the secondary windings. So the reason for this is simply that is a time varying flux. Now once if the induced EMF exists or some amount of EMF induced across the secondary winding, now this becomes the voltage source, and this can easily supply some amount of electrical power to the load connected across it. So whenever load is connected here across the secondary winding, then simply this E2 will drive some amount of current through the load. Like this, we can drive some amount of load. So what happens, these are the various steps involved once the primary winding is excited with some amount of supply voltage. So once this V1 is supplied or applied to this primary winding, I1 it will be established. Whenever this I1 passes through this winding, so there will be a flux, and once this flux is driven means because of some moment magnetomotive force, that is nothing but N1 into I1. This is nothing but ampere turns. So this will be the equivalent of electrical voltage in the magnetomotive force, that is called as a MMF. Because of this MMF, there will be a magnetic flux. It will be generated at the primary, and it will pass on to the secondary winding, and it will come back to the primary winding. Like this, flux will flows through the magnetic core, or this is the magnetic path, and this will be made with some special grade silicon material in order to reduce some magnetic losses like hysteresis and eddy current losses. Of course, anyhow, we are going to discuss in this today's video session only what are the various types of magnetic losses. And this, whenever this magnetic flux, time varying flux passes through the secondary winding, there will be induced EMF. Now if the load, if you want to drive, just connect the load across the secondary winding. Now some amount of current it will be supplied to the load. Like this, the secondary winding, it is capable to drive some amount of load which is connected across the secondary winding. So it means, see here, this voltage, now here it is converted into the magnetic field. And again, this magnetic energy is converted into the electrical energy here. This electrical energy is supplied to the load. So because of this conversion of energy is taking place, Now, whenever we are traveling from primary to the secondary, once that electrical energy is converting into the magnetic energy, then magnetic energy is again converted into the electrical energy. So, like this, there are two stages of energy conversion is taking place. That's why now this is a transformer. This transformer is called as a electromagnetic energy conversion device. So, the source for this flux is nothing but, it will be driven by magnetomotive force. So, this magnetomotive force is nothing but just like a EMF in our electrostatic fields or in the electrical engineering. So, this is the formula for is nothing but N into current. So, number of turns into current, it is gives us how much of magnetomotive force it will be generated, and this magnetomotive force is capable to drive some amount of flux. So, the reason for this magnetomotive force is nothing but the number of turns and current. So, this current is passing through this many number of turns. So, definitely there exists MMF, magnetomotive force, across the primary winding. So, magnetomotive force is nothing but just like a voltage or induced EMF in the electrical field. So, this as electromotive force or EMF is capable to generate some amount of current once it is able to find a closed path. In the same manner, this magnetomotive force also, it can easily drive some amount of flux, magnetic flux, once it is able to find a closed path. So, that closed path, it will be provided by this a core that is a magnetic material made with in order to perform some magnetic core is available. So, this magnetic core, we can get some magnetic flux. So, the reason for this magnetic flux is MMF. The reason for this magnetomotive force is nothing but the current. Now, please try to remember this particular point. Now, again, this will comes in the forthcoming videos. So, this magnetomotive force is capable to drive some amount of magnetic flux. So, similarly, now across the secondary winding also, now there may be some magnetomotive force, N2, I2. I2 is capable to drive through N2 number of turns. So, here also you will get some magnetomotive force. Now, suppose once this load is connected, I2 will comes into picture. Now, I2 is comes into picture means it is also capable to drive some amount of flux lines. That we will discuss. So, first, I think it is very clear that this transformer is nothing but it is an electromagnetic energy conversion device. So, the transformer is a device that transfers electrical energy from one electrical circuit to the another electrical circuit. So, this is one electrical circuit. This primary is nothing but this is the one electrical circuit. This is the another electrical circuit. And it is also very important thing we have to remember that this primary and secondary are not electrically connected. These two are primary winding and secondary winding, or primary loop and secondary loop are electrically separated but magnetically connected. And there is no electrical connection between the primary loop and the secondary loop. Only these primary and secondary loops are connected by means of a magnetic circuit. Even though the voltage, how much we are applying across the primary winding, it will be transferred to the secondary winding, because that electromagnetic energy conversion is taking place in between. So, that will convert electrical energy, it will be transformed from one circuit to the another circuit. So, what happens once that electrical energy transfers from one level to the another level means there may be a change in the voltage or there may be a change in the current. So, based on this, there are two types of transformers we can talk. The transformer is nothing but, suppose if the primary voltage is V1 and secondary voltage is V2. If primary voltage is less than the secondary voltage, if V2 is larger than this is nothing but it is called as the step-up transformer. If V1 is greater than V2, means this is nothing but the step-down transformer. It means the transformer is a device which changes or which transfers electrical energy from one circuit to the another circuit in changing the voltage values or current values. The voltage may be increased or current may be increased. So, what are the parameters? How this voltage it will be increased? How the voltage it will be decreased in the secondary winding means based on the number of turns that we will discuss. First, let me clarify this. What are the types of the transformer based on the voltage levels? Based on the voltage levels, the transformers can be classified into two things. One is the step-up transformer. Next one is the step-down transformer. Step-up transformer means if the output voltage, it means secondary voltage, is greater than the primary voltage, then that is the step up. And if the primary voltage is greater than the secondary voltage, that is nothing but the step down transformer. So like this, based on the voltage level, transformers can be classified. And here the very important point here is only the voltages and currents may be changed. Only voltage and current may be changed. But what about the frequency? Because frequency is one of the major part and very important point in the AC circuits. And here in the transformer, even though if the voltage levels may be changed from primary to secondary, current levels may also change from primary to the secondary, but frequency never change. Frequency will remain same. That is a very important point. Now, why the frequency is same? Why the frequency is same means because in the transformer, all the parts, all the components are static in the nature. There are no rotating bodies. If there are no rotating bodies, there is no question of the change in the frequency, because if there are no rotating parts means we cannot define the speed. Once the speed is not applicable, then frequency will always remains same. That is the beauty of this transformer. Even though the voltages, currents may be changed in order to achieve some of the local applications, but the frequency remains same. So that is one of the important points, and it is widely used. The majority of the components in the power systems are single phase transformers and three phase transformers. So it works on the principle of mutual induction. Just now also we have discussed elaborately. So it works on the principle of mutual induction between two magnetically coupled coils, because the two coils are nothing but the windings. The two windings, what are the two windings? Primary winding and the secondary winding. This primary winding and secondary windings are magnetically coupled but electrically separated. Now, when this alternating flux links not only the primary winding but also the secondary windings. Now, when the supply voltage is switched on, then there will be a magnetic flux. It will passes through the primary and as well as to the secondary, and again secondary to the primary to the secondary. Now, there will be a circulation of this alternating flux through the magnetic core. Now, here the properties of the magnetic core, it is very important. It should have low reluctance. Low reluctance means reluctance is nothing but some type of opposition to the flow of flux. So once the opposition is reduced, then we can get the maximum amount of linkage between the primary coil and the secondary coil. So in order to utilize effectively the total flux available in the primary, across the primary, so the material you have to choose such that the reluctance, that magnetic reluctance of the path should be very low. So like this, we are going to choose the material for the construction of the magnetic core. So what about the induced EMF in the primary winding? So in the as per the Faraday's laws of electromagnetic induction, that induced EMF is directly proportional to the number of flux cuttings or rate of change of flux cuttings. So or rate of change of flux linkages. So that is a more apt definition, that induced EMF is directly proportional to the rate of change of flux linkages. So how many flux linkages in the primary winding? How many number of turns, and what could be the flux? So number of turns are nothing but the N1, and in the secondary number of turns are nothing but the N2. Why there is a negative? Because as per the Lenz law, always this induced EMF, it will oppose the cause. So what could be the cause for the primary induced EMF? Supply voltage is the cause. So the direction of the primary induced EMF is always in the opposite direction to the supply voltage. So that's why as per the Lenz law, now we are keeping minus for the induced EMF 1 and for the induced EMF in the secondary winding, that is E2. So E1 is equal to minus N1 into d phi by dt, E2 is equal to minus N2 into d phi by dt. Now here one thing we have to remember, throughout this operation we are not talking about the load. So it means the secondary is, we have not connected anything across the secondary winding. So if you are taking the ratio between E1 to E2 or E2 to E1, E2 by E1 is nothing but d phi by dt is common term from the numerator and the denominator. So remaining term is nothing but the N2 by N1. So E2 by E1 is equal to N2 by N1 is equal to K. This is called as a transformation ratio. This is a very important, this transformation ratio. So the directions of induced EMF, just now also we have discussed that always E1 and E2s are in the opposite direction to the supply voltage as per the Lenz law. So suppose if the power factors of the primary loop primary winding and the secondary winding or primary loop and the secondary loop is same, then whatever the single phase power E1, V1, I1, so power formula is V1, I1 into cos pi 1, and secondary winding is nothing but the V2, I2 cos pi 2. If the power factors are same, then this will be the same. So if the then whatever this V1 value and the V2 value and for the same power factor, so it means either V1, E1, no matters here, E1, I1 is equal to E2, I2, because the change of the electrical power from one level to the another level. So what happens if you are simplifying this expression, E2 by E1 is equal to N2 by N1 is nothing but the I1 by I2. Now this is a very, very important point. Now E2 by E1 is equal to N2 by N1, already we have solved this, and if we are rearranging this particular simple expression, E1 to E2 is equal to I2 to I1, or reciprocal if you are taking E2 by E1 is equal to I1 by I2, that is the transformation ratio. So this transformation ratio is very, very helpful for us in solving or in designing the transformer also. So that's why this transformation ratio is very, very important. And in terms of the voltage also you can write, in terms of the voltage means V2 by V1 is equal to E2 by E1 is equal to N2 by N1. Everything is 2 to 1 but except current. In the current I1 to I2 we have to take. So that is nothing but the transformation ratio. Thank you for watching this video. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.